Everyone, welcome back. This is Engineer Hussein Masapi. So in this video, we'll be looking at what are called ordinary differential equations. So let's try and understand what ODEs are. But before we do not forget to like and subscribe to the channel. Alright, so let's begin. So to understand ODEs, you first have to know the definition. So by definition, ordinary differential equations are simply differential equations that contains differential coefficients. Let me try and paint the picture clearly. When we say it's an equation, we need to bear in mind that we're talking about something that will contain an equal sign. But the fact that we have put in question that they contain differential coefficients, it's quite important that we understand what they are. So differential coefficients are dy over dx, or it could be f prime of x, or even a delta y over delta x symbol. Now, there are many forms of notations that people would use to show that it's a differential coefficient, but these are the most common ones that you would find. Now, apart from knowing what a differential equation is, or ordinary differential equation in particular, we need to understand what are called orders and degrees of differential equations. Now, when we talk about an order, we're talking about the highest derivative that occurs in the equation. Like, what's the highest derivative that's present there? Is it the second, third, fourth? Now, it depends with what you have been given in question. The highest degree will show you the order of a differential equation. Knowing the order is quite important to understand the technique in which you use to solve the particular equation that you might have. Now, if you look at a degree is basically the highest power of the highest derivative in a differential equation, which basically just tells you to say that it's the highest power of the order of the differential equation. Now, knowing just the definition and what an order or degree of a differential equation is, it's quite also paramount to understand how these things can be illustrated through examples. So with an example, let's try and find the order as well as the degree. Say you have d squared y over dx squared plus 3x minus open parenthesis d to the fourth y over dx to the fourth close parenthesis raised to the power of 3. And because it's an equation, let's equate this to 0. Now, let us determine the order. Now, remember, by definition, we're saying the order is basically the highest derivative that occurs in an equation. So, we're having the second derivative there. We're also having another derivative within the parenthesis here. And this is the fourth derivative. Now, between the second and the fourth derivative, one can understand the fourth derivative is the highest order. So, the highest derivative we have here is the fourth derivative, which tells us to say that the order is the fourth order. Now, let's try and find the degree. We're saying that the degree is basically the highest power of the highest order. Now, the reason why I'm saying that it's the highest power of the highest derivative in a differential equation is that what if you had different. Okay, let me try and paint the picture to you. Now, imagine if we also had something like d to the fourth y over dx to the fourth just hanging around this particular equation. We'd understand that the power of this is basically 1. So we need to distinguish what we're trying to elaborate. So with that in mind, let's understand that the degree in this question we have in particular will be the third degree, because that's the highest power of the highest derivative in question. So we say the third degree. Now, the next thing we should know is that every time we're solving differential equations, we end up finding some solutions because to every problem, you expect to have a solution to it. But now we need to know the types of solutions we'll come across. So we're going to look at the types of solutions that we might find. Now, the first type of solution that we may look at is a general solution. Now, a general solution is where you have a differential equation that contains arbitrarily what? Constants. Then the second one is called a particular solution, where a differential equation will be having constants that are determined by particular initial conditions. So now imagine in a general solution, you're having arbitrary constants, could be C or whatever variable they would choose. Now, let's imagine that we solved for that particular C. Then what we'll be having is a particular solution because that solution has a value attached to it. I hope that's clear. So now, let's try to also understand this with an example, just to clear the concept. So let's take, for instance, we have two statements. Let's take two statements, some random statements. Let's take, for instance, we have, say, f prime of x is equal to 2x. So now we know that this is the first derivative. Now imagine if we get two types of solutions. Let's say the first solution star is y is equal to x squared plus c. And then the second solution star is y is equal to x squared plus 3. Now between the two, we need to understand which one is going to be the general and which one is going to be the particular solution. So according to the definition, we can say that the one having the arbitrarily constant c is basically the general solution. And now the one having the arbitrarily constant c evaluated to be a value such as 3, say there were some initial conditions attached to it, then this is called the particular solution, because now we have the solution in particular. All right, so this is something that you need to know. So every time you're looking at ODEs, you have to understand the definition. Definition will give you that mindset to know that, okay, this is what I'm going to be understanding in this particular topic. Then not only that, you should know the degree and the order that is present. And then you need to know the types of solutions that we might have. All right, thanks for watching. If you have any queries, you can reach out to me on WhatsApp on the line +260 77 5252. Remember, slow progress is better than no progress, and let's strategize before becoming a statistic. Let's try and push for that A+.